participants have rolled in, so we'll get this started. So my name is Matthew Watkins. I am the current chair of the Sustainability Commission and part of the Energy Task Force that helped put together tonight's talk. I'd like to start by acknowledging that we're hosting this event from the traditional territories of the Synax, the Salix, the Silkwepum, and the Tunahas people. I mentioned this last time, but it's worth reiterating just the importance of acknowledging and remembering the cultural impact of the damming of the Columbia had on regional Indigenous communities. I recently read an interesting quote on the government webpage that states, quote, "It is acknowledged by the BC government today that consultations with First Nations at the time could be considered inadequate to non-existent by today's standards." Perhaps an understatement. So for those of you that are joining us for the first time tonight, there we go. This talk is part of a series of talks that the Energy Task Force is putting on this winter, all focused around home energy retrofits. So this is the second talk in the series. The third talk got moved since we last spoke, and it's going to be on Thursday, February 10th, and it's going to focus on air tightness and ventilation. And then 2 weeks from that will be February 23rd. We're going to look at insulation and windows. And on March 9th, we're going to look at heat pumps. And we've got Better Homes BC is going to come in and do their heat pump talk that they do for different cities. So that should be good. And then the final talk is going to be on March 23rd. And we're going to do a deep dive into 2 local deep energy retrofits where 2 homeowners took different approaches, but both drastically cut the energy consumptions of their homes. We're going to try and cover these key aspects of home energy retrofits, and we're going to try and draw on as much local experience and knowledge as we can to really base it in like the Roslyn experience. And I'd like to give a big thank to the Energy Task Force team, which is Ken Holmes and Margot Lohr, for helping put together this series of talks. So tonight's talk is going to focus on assessments and behaviors. So I'm going to start off by going over some of the DIY approaches to home energy assessments, benchmarking, walkthrough assessments. I'll mention modeling. And then Bruce Edson, a professional home energy advisor, has joined us tonight, and he's going to walk us through the EnerGuide home energy efficiency evaluations and what a professional can bring to your home energy retrofit from an energy advisor perspective. And then the second part of the presentation, I will get into some of the behavioral aspects of energy conservation. And we're going to finish with a Q&A. And we're lucky to be joined by Alex Loeb and Terry Miller, who are both former heads of the Sustainability Commission, is my understanding. And they have recently gone through energy assessments with home energy retrofits. And then Ken Holmes is also joining us. And Ken is a local retired professional engineer and certified energy manager. Ken has been working on energy-related matters in Roslyn for decades. If he doesn't know the answer, he knows how to find the answer very quickly. So he's going to be joining us for the Q&A as well. We're going to hold questions until that time, and then we'll open it up to try to get everything answered. All right, so moving into energy assessments. So last talk, I talked about the energy efficiency pyramid and the importance of starting at the bottom of a sorry, I just got there you go. Okay, sorry, I got distracted by a raised hand. So just the importance of the energy efficiency pyramid in terms of starting with a solid foundation and how that solid foundation affects the efficiency and efficacy of actions that are taken further up the pyramid, as well as how complexity and cost increase as you go up that pyramid. So tonight we're going to be starting naturally at the bottom of the pyramid. So benchmarking is basically the simplest way to come into home energy evaluations. It's a method used to determine whether a home is using more or less energy than other homes of similar occupancy or size. It's basically measuring the household energy use, standardizing the units, and standardizing it to the size of a home. This allows you to both create a baseline to measure against if you're going to make any efficiency changes or conservation changes. So you can go back to this baseline and see how those changes impacted energy use. And it also gives you the ability to compare it to other similar homes within your region. So you can compare it to other people in your neighborhood if they've undergone one, and it gives you sort of a relative scale of how you're doing. Ken has developed, let's see how good I am at this. Ken Holmes has developed a benchmark for us here in Rossland, and I'll share this with everybody. I'll send this out in an email to all the attendees afterwards, but basically this is a template that Ken has put together that walks you through doing a benchmark on your own home. The red fields are fields that you have to enter, and then the yellow fields are auto-populated that Ken has created. These fields, the red fields, can all be taken off of your Fortis bill, and Ken walks through the step-by-step details on how to do that. We're trying to put together a database of homes in Rossland that do this benchmarking, in the hope to just give people the ability to compare their homes to others. So if you'd like to contribute to this database, you can go through this benchmarking tool and send your results to the Sustainability Commission, and we'll add it to the database so that people can get a comparison. You can see that there's no information here that is particular to your or identifiable to your home. So going over the benefits of benchmarking. So I already commented on the ability to set a baseline from which to measure, as well as to measure against other people. There's also proven impact of benchmarking on conservation behavior by homeowners. So a recent study of 9,000 homes in the States show that homes that underwent benchmarking reduced their consumption by 3% relative to homes that did not undertake benchmarking. So this just simple process of measuring what you're consuming and comparing it to other people has a real net benefit effect to reducing consumption. It is also no cost and relatively low effort as far as energy evaluations go. There are a couple limitations. The biggest one is that it doesn't provide a pathway from which to address the number that comes out. So it'll give you a number, but it doesn't tell you the best options in terms of improving that number. And it also doesn't necessarily distinguish between conservation and efficiency. So you can have a very inefficient home that just doesn't turn up their heat or doesn't use much hot water and is going to look pretty good on a benchmark. And you can have a very efficient home, but it's 30 degrees and they have the hot water tap running all the time. So it doesn't necessarily distinguish between conservation and efficiency. Ken also put together and did a energy talk 2 years ago now, or just over a year ago, on benchmarking. So the entire energy talk, I believe it's an hour long with question and answers, addresses benchmarking explicitly. So if you want to dive deeper into benchmarking, that's a good resource. So DIY assessments, you can find a lot of these on the internet. The one I'm going to share City of Vancouver put together one that I quite like. I'll share this file with everybody as well. This will be part of the email I send out. So one of the benefits of walk-through assessment tools like this is that they force a comprehensive approach to looking at your home. So often we'll see, little things that we'll be aware of that we might address, but we rarely go around and systematically look at every aspect of our home and measure and evaluate the ways in which we can improve it or the way in which it's affecting our energy use. So one of the major benefits of an approach like this is that, as you can see, it takes you through a checklist of very specific details around your entire house that cover all aspects of home energy use and efficiency. This guide, I like this guide in particular because it does a very good job, I find, of introducing you to some of the different key areas and giving you instructions on how to take those measurements. So if we look, for example, insulation, it talks about what insulation is, how to look for it in different parts of your home and specific things to be looking for. Gives you a standard of what you should be, trying to achieve. So that this is one. There are, like I said, you can find lots of these DIY tools for assessment, but that is one that I particularly like. Where's my cursor? So encourages a comprehensive approach. It also provides some direction because unlike a benchmark, these assessment tools are actually looking at individual details in your home. And so they will give you some sense of where you'll get returns on effort. And they are low cost and they're moderate amount of effort. So they're more effort than benchmarking for sure. Some limitations with them is that there's very strong correlation to your knowledge and experience. So the more knowledge you bring to bear on one of these assessments, the better results you're going to get. So that's definitely a limitation. If you're new to home construction or home energy renovations, hopefully you'll learn a bit through this series, but it might not be as effective for you. And as a DIYer, you're also likely to be limited in tools and instruments you have. So a blower door is a very good example of this. Bruce, I'm sure, will talk about a blower door test later on, but it's essentially a way of depressurizing your home, which allows you to measure air changes in your home or how much the wind blows through it, and helps identify the areas in which the wind is blowing through your home so that you can address those. So the Sustainability Commission is putting together a DIY assessment kit here in Rossland, and this is going to be available at the library for rent for free. And it's going to comprise of two things. One will be a watt meter. So this will allow you to plug in appliances such as your fridge to understand the energy that they're drawing. So if you have an older fridge, you're not sure how efficient it is, you're looking at a newer fridge, this will give you, real data around the difference in both cost and energy consumption. And then we also purchased a infrared camera that adapts to your phone. So you'll be able to plug it into your phone and you'll be able to walk around your house and look at different aspects of your house and get a good sense of where you're missing insulation, where there's air coming in, air leakage, where there's thermal bridging. So help direct some of your efforts around renovations or retrofits. And instructions on these two will be with the kits available in the library. All right, that brings us to, oh, I should mention one more thing. There are DIY modeling tools that you can use for your home. Passive House has one that you can use. I believe there's a free version of Hot 2000, which is a instrument or a modeling program created by the Government of Canada. They are a step up from this walkthrough checklist that I talked about. You're putting in a lot more data and you're getting a lot more specifics out of it. I didn't go over it comprehensively here because if you're doing that, then you've got the time and energy and understanding to learn more about it yourself. It's definitely a step above these other assessment tools that I've covered here. All right, Bruce, that leaves us with you. Would you like to walk us through your approach?
Yeah. Hi, everyone. I'm Bruce Edson. Hopefully you can get my screen there. And I work for a company called EcoFit. We do a number of different energy projects, including inner guide assessments, but also we run the ECAP program, which is, I think, worth mentioning because I use that every day. And that's the Energy Conservation Assistance Program for income qualified people, which is also uses energy modeling to assess the potential for upgrades to houses. And that's run by Fortis and BC Hydro. So anyway, what is an EA? That's what I do, and I work in conjunction with various granting programs to do energy modeling. It's a program, the EA program is part of the Inner Guide program. That's the stickers you put on your fridge and such. That and also computers. I think it started in the US with computers and then kind of branched out. But now they have a label for houses. And to get a label for your house, it has to be modeled for energy efficiency by an energy advisor. So generally, energy advisors come from various backgrounds. They can be contractors, engineers, architects, home inspectors, building science experts. And the skills needed are just basically knowledge of construction, knowledge of energy dynamics in a house, and a lot of math and geometry. So if you are getting energy assessment, what to expect? Basically, it usually takes me 2 to 3 hours. It can take even more than that sometimes, depending on the complexity of the house. So what my job is I try and model the house as accurately as possible, looking at all the components, such as insulation, foundation, whatever is in the house that it's going to affect the energy dynamics of that house, including air leakage. One of the things that I wanted to touch on that we look at also is if a house can become dangerous. And sometimes houses, especially the tighter new ones, if you really air seal your house, it can make it too airtight. And if you had a wood stove or something in there, it can create issues whereas instead of going up the flue, the combustion gases go down the flue and into your house. And that might happen if you had all of your fans on in your house. It would actually depressurize the house to the point where it competes with the natural tendency of air to rise up the flue and sucks it into the house. And that's what contributes to carbon monoxide poisoning. So as an energy advisor, in every assessment, we always look for potential for carbon monoxide poison risk and kind of advise on the balance between air sealing, ventilation, and the risk for carbon monoxide in a house, because it's always in any renovation energy upgrade plan, it's really important to keep that in mind. one of the things we do towards the end of the test is a blower door test. Now, what that does is has a giant fan here, and that sucks out a lot of the air in the house to a pressure of 50 pascals difference between the inside and the outside. So what that in effect does is every air leakage spot in the house, it starts sucking air in. So it becomes a lot easier to see where the air leakage spots are. So some energy advisors will use smoke guns like this guy's using. You can see the smoke kind of coming off of that when the blower door is on. It'll suck it right in like that. So it's really valuable for homeowners to see that, so that they know the spots that they're going to want to air seal afterwards. So it's a lot of homes, especially in our area where there's lots of older homes, it's real low hanging fruit. There's massive gaps that are easy to air seal. So it's really valuable for the blower door. So the blower door also gives you more of we enter it into software, and it comes up with the air changes per hour in your house, and that affects ventilation needs of the house. Because if your house is too tight, if you tighten it up too much, you may have to add ventilation to it, because a house is typically naturally ventilated. So especially the older ones, if you tighten it up, you may need to consider adding mechanical ventilation of some kind. So the other things that are useful to bear in mind as you really make your house more energy efficient, and that's basically a lot of what EAs do, is consult on that and some of the pitfalls associated with projects such as moisture dynamics too, because you can also kind of screw up your house with when you tighten it up by trapping moisture in it. So what's the result of the inner guide process is basically you get a label that shows you your energy usage. And that is in gigajoules per year. So this is kind of a combination of the thermal envelope, all of the mechanical stuff in the house. What's your house using per year? And it also gives you a breakdown of your consumption. So this is kind of that label we were talking about, how overall your energy efficiency of the house is. It also gives you a more thorough report of the state of your house. So this is called the homeowner information sheet. And when we put all of our model into the software, this is what it kind of spits out in the graphical format. So a lot of useful information here, such as this area here shows you the energy usage and also where your house loses heat, so you know where to focus on. In this case, this house was losing a lot of heat through the basement. So it might be something to consider adding insulation to the basement before the attic here, since it's such a bigger, you get more bang for your buck by insulating that basement in this particular house. So useful information for the homeowner. Another thing is we can find out what the heating load is of the house, and that might be useful if you're adding a heat pump or something for sizing. And what else we got here? Air leakage, of course. In air changes per hour, equivalent leakage area, that's how big the hole is in your house, basically, like that's all the little holes put together into one hole. Another thing an EA does is renovation upgrade report. So we suggest upgrades for your home, and the software provides the relative benefit based on how accurate our initial model was when we went around and gathered information. Yeah, so you can use this to prioritize your upgrades. I don't know how that, I tend to go over, so I'm going to stop there if there's any questions from the other panelists that might be useful, just to answer those for a few minutes here, or move on to the next segment. Thanks.
Thanks, Bruce. That is a great overview of what people can expect from you there. I'll go back to sharing. So Bruce is going to stick around and will be with us at the end of the presentation. So any questions that people have about the specifics can raise them then. So just to break down a few of the specific benefits and limitations of professional assessments that energy advisors such as Bruce can bring, is the biggest one is experience and expertise. So this is their job, not their first rodeo. They've seen a lot of homes. They can bring substantial expertise to bear on your project. Like Bruce showed with his blower door, they can also bring the appropriate tools and instruments to get the best out of an assessment. And I think one of the most important things is the detailed roadmap that they can provide in terms of showing you exactly where your weaknesses are and where your efforts can go to greatest effect the energy use of your home. And we talked about this last talk, but home energy assessments are energy-guided ones are often needed to be able to access rebates. So there's certain rebates in retrofits where you have to get one of these assessments done if you want to get those rebates. Some limitations, they're not free. There's some variability in expertise. So the actual EA accreditation doesn't take a lot, but energy advisors will often have a lot of different accreditation or different experience behind them. And so it's something to look at when you're hiring one, is that there's sort of different experience and expertise. And then access. So I brought this up last time and Bruce corrected me. I was not aware of any energy advisors servicing Roslyn for retrofits. Bruce is the only regional one that I'm aware of now doing it. It seems like there's a couple that say they do it out of Kelowna, but from what I've heard, it's very difficult to get them on site. So hate to expose everybody to pickles and peanut butter again. I brought this up the last talk. This is an analogy that I picked up from Alex when I was speaking to her to get ready for my last talk. And I've roughly applied it to home energy retrofits, and in this case, assessments. So understanding what you're trying to do in your retrofit. So how big a project are you looking to take on? And what kind of knowledge do you as an individual bring to bear on that project? And so you can go from really simple, straightforward, to quite complex, vegan pad thai, peanut butter sandwich. As you get more complex, you'll want to reach out more and more to professionals. The one thing that I would recommend, having been through this myself and having had some background in building and understanding of building science, is not to overestimate your knowledge around the subject matter. The money that you spend to get a professional energy advisor into your home is money well spent if you're doing much at all in terms of home energy renovations or retrofits. All right, so moving on, we're going to get into some of the behavioral aspects of home energy conservation. Oh, did you have a comment there, Ken? I think you can unmute yourself.
Yeah, I think it's important to recognize that energy modeling is a theoretical simulation of your house. And the results can sometimes bear no resemblance whatsoever to the actual energy consumption in practice. You can compare this to if you buy a new car, the specs of the car give you the fuel consumption, liters per 100 kilometers or whatever. And what you actually achieve in practice depends on how you drive the car, how big a lead foot you have, and so on and so forth. And it's the same with a house. how you operate the house, which you might get into in the behavioral aspect, has a big impact. So when you look at an energy modeling report, sometimes the absolute numbers can be way off mark, but the relative numbers in terms of percentage savings can be fairly accurate. I know in the case of my house, I first had it modeled in 2005 by a guy, an energy advisor from Victoria. The number he came up with was 90% higher than what I averaged over about 7 years of energy bills. When I had the energy modeling done after I'd been on my upgrades, it was a different guy from Kamloops, and he was also in error by something like 75 to 80%. So I think you have to take the numbers with a grain of salt and be able to interpret what you might save as a percentage rather than absolute numbers. I think there's a good quote from an economist in the UK, said, all models are wrong, but some are useful. And the trick is to decide how wrong they can be and still be useful.
That's great. Thanks for that, Ken. All right, so we're going to get into some of the behavioral aspects of energy conservation in the home here. And I'm going to try my hand with some polls just to make it a little bit more interactive here. So, according to Natural Resources Canada, what percentage of energy used in Canadian homes goes towards space heating? You just see how many people we have, 22. All right, so people are guessing at the high end here. I'll end there. So 10 of you, if I'm reading this correctly, 10 of 14 of you guessed 62%, which is in fact accurate. How do I put that on? So here's a breakdown of home energy use in Canada. Now, last talk, I had a different graph with some roughly different numbers. I think it was focused on BC, and I think it was focused on detached homes. But as you can see here, nonetheless, space heating eats up a massive chunk of our energy use in our homes here in Canada, followed a long way back by water heating, appliances, and lighting. Space cooling is a number that is relatively small right now, but is on the rise. I haven't seen the stats, but I have no doubt that last summer's heat dome led to a record sale of home cooling units in British Columbia. So that's going to become more and more a factor. So some tips and tricks around reducing space heating from a behavioral perspective. I like this quote that I saw: heat yourself and then your home. So this is basically dress warm in the winter, wear slippers, you're going skiing anyway, so you might as well put on your thermals in the morning. Wool sweaters, put on a wool sweater before you touch the thermostat. Another good point about this is to heat the spaces that you're in. So if you're spending your evening in one room, maybe bringing a space heater into that room so that your central air can be lowered, so you're not heating the rest of the house, and you can use less energy by just heating that room. So a second one will be to turn your heat down. So this is Fortis recommendations, I believe, which recommends 16 degrees at night, 18 degrees during the day when you're sort of on your feet, up and about, in the kitchen or doing whatever, and then 21 sort of in more sedentary. So if you're sitting behind a desk in the home office, or if you're sitting on a couch, hopefully you have a blanket on, but basically a bit warmer when you're sitting around. So this, I'm going to launch another poll here, which I thought was very interesting. And this is around, according to Natural Resources Canada, what percentage of Canadian households lower the temperatures of their home when they're asleep? %35%. That I was, so what percentage lower it, right? Lower their heat. Okay. I was shocked that the answer is actually 55%. So I was shocked at how low that was. I thought that that was going to be a much higher number. One way in which the number increases is through the use of programmable thermostat. So 55% of Canadian households turn their heat down at night. In general, that number jumps to 80% of households with programmable thermostats turn their heat down at night. So if you're one of those people that doesn't always remember to turn the heat down, a programmable thermostat is proven to be very effective at increasing that behavior. Another stat here, according to research conducted by the Canadian Centre for Housing Technology, reducing temperatures to 16 degrees at night and when your dwelling is unoccupied in the day can result in a 13% reduction in the amount of heating used. Terry, did you have a question there?
Well, there's a question in the chat, and as I read it a couple times, it came up for me too. At the bottom of that slide, you say renewable natural gas, and La Rochelle asked, "What is renewable natural gas?" Sorry,
Thank you.
off topic there.
I'll work my way down there here.
Okay.
So another easy thing to do, reverse your ceiling fan. So a lot of people don't know that ceiling fans will go in both directions. So in the winter, it's best to have it blowing up so that the hot air gets pushed to the ceiling and then down the sides and runs down the side of your room. And that doesn't put air right over your body, which will cool you down. Whereas in the summer, you turn it to push down so you have direct air coming over off your skin that helps evaporate water off your skin and cool you down. Curtains is another big thing in homes with a lot of windows. So by closing your curtains, you're reducing the convective effects of heat in your home, where you can actually get sort of measurable drafts from air that's falling down off those cold windows and then coming across your floor, right at couch level. It can really cool you down. Natural gas, or renewable natural gas, is something that I just learned about. Freya brought this up at the last talk, and I didn't know anything about it. So Fortis has a bunch of biogas plants, essentially, where they're pulling gas off of things whose gas would otherwise just be going into the atmosphere. So commercial composting places, they're capturing the methane that's coming off of those, and they're sticking it in a pipe and bringing it to your home. They're also using agricultural waste, so waste from cows on dairy lots. And I believe they're also using some wood. So I looked into natural gas, and it is a price increase, there's no question. For my house, for the year, you can also, so I should mention, so you can sign up for this on Fortis, and you can state the percentage of your natural gas that you want to come from renewable natural gas. So you can say I only want 5% of my gas to come from renewable, or I want 50, or I want 100% of my natural gas to come from these renewable sources. So the price impact can vary greatly. For my home here in Rossland, 100%, switching over to 100% renewable natural gas cost me around $250 a year extra based on my other gas bill. One note about renewable natural gas is that I view it as a stepping stone or a crutch to other forms of efficiencies towards electrification. A lot of the places where this renewable natural gas is coming from, such as, for example, dairy farms, aren't sustainable in themselves. So there's a question as to, how renewable that natural gas really is in the long run. Ken, did you have a comment?
Yeah, just out of interest, there's a company planning to build a renewable natural gas plant in Fruitvale on the old ATCO site, using wood waste as the source of energy.
Right.
And the gas will go into the Fortis system.
Okay, there you go, local. Yeah, okay. All right, moving on to the second largest aspect of home energy use, and that's water heating. And I've got another poll, if we can find the notes. So, according to Natural Resources Canada, how much hot water does the average Canadian use at home every day? So how much hot water does the average Canadian use at home every day? So this was another one that I had to double check. I had written it in my notes, and I can see that I didn't correct it in the question itself, because I questioned whether the stat was for water or for hot water. Because in fact, the average Canadian uses 75 liters of hot water in their home every day, which looks like 7 of 15 of you guessed correctly. So you can see a breakdown here of that hot water use in the homes. How the different ways in which they're using it. That leaks was an interesting one that was much higher than I would have guessed as well. So a few things to keep in mind when reducing water heating needs is to use less. So shower instead of bath. According to BC Hydro, a bath uses about 3 to 6 times more water than a 5-minute shower. So if you can stick to showers, you're going to reduce your use. If you can stick to washing dishes over washing dishes in a sink, using a dishwasher, instead of in the sink, is another way. 80% of the energy used in a dishwasher is the energy of the water, the hot water. And with Energy Star dishwashers, they're required to use less than 14 liters of water per cycle. So trying to wash an entire dishwasher worth of dishes by hand in a sink with less than that is definitely achievable, but it requires a lot of attention, and for most of us, we are not achieving that. Another one, with dishwashing too, if you're using your dishwasher, skipping the heat cycle at the end. So just opening up your dishwasher and letting it air dry instead of using the energy to heat up the dishwasher and dry the dishes that way is another way. And then washing your clothes on cold versus hot. Similar to dishwashers, the bulk of the energy used in washing machines is around the heat use of the water. So you can switch to clothes. You're going to greatly reduce your energy consumption, and you're going to greatly increase the longevity of your clothing. A final one, this isn't behavioral, this requires an installation, but installing water sense aerators on taps and on faucets and shower heads can greatly reduce the amount of water used. I've got a stat here somewhere. These shower heads use half to 1/3 of the water that some older shower heads use. So another trick, which I've never seen here in Canada, but is common in other parts of the world, is to put your water tank on a timer. So the recommended, what I read, they recommended was to put it on for 30 minutes in the morning, like right before usage. So if you're normally up at 6, turn it on, have the timer turn on for 5:30, heats the water tank up, turns off. In the evening, you're back using hot water on dinner time at 6 again, tank goes on at 5:30, heats the water up. And that's more efficient than having the tank keeping itself warm all the time. Another thing which can be done and is common in New Zealand, I know, is to just have your tank fill up once a day. So where places where the energy rates are varied through the day, they'll often have this where the timer only turns the hot water heater on where energy cost is the lowest, and then you get one tank for the day. And when you're done that tank, the next person in the shower is going to be talking to the person before about the length of their shower. So it's a good way to sort of force modified behavior around hot water consumption. Another one is to turn your hot water heater down. This has a caveat with it. So for electrical tanks in BC, the plumbing code has a requirement of 60 degrees at the tank. That's for bacterial growth and health in the water. This doesn't apply to gas heaters. I'm not sure what the difference is there, but gas you're allowed to turn down, and optimal tap temp is 49 degrees. So you've got some room to play with there and bring that temperature down. And finally, when your tank does die, think about going with a heat pump water heater. These are up to 200% more efficient than your standard electric water heater. All right, finally, appliances. So this graph on the right shows residential energy use in appliance stock index for 1990 and 2016. And the things that really jumped out at me here are, you can see, let's see if I can move. The lines show the relative increase of the abundance of small and large appliances in Canadian homes. And so you can see, if you're looking at the blue line, that major appliances increase. So there's many more in 2017 as there are, well, it's interesting, I got the numbers wrong, in 1990, but the energy consumption of those, despite that, has actually decreased. So there's been significant energy efficiency gains in major appliances over that time period. If you look at the red line, that's the increase in minor appliances in our household, such as TVs, computers, mobile phones, and such over that time period. And you can see that that's just exploded. And the efficiency gains in those type of units has not been realized. So that increase of number of units has directly translated into increase of energy use. So overall, despite great gains in the efficiency of large appliances, overall energy consumption is up because of the uptake of small appliances. So a couple approaches to managing this that can be done from a behavioral perspective. is to turn stuff off. And this is pretty interesting. I think, do I have a, yeah, I've got a stat about this as well. But when I say turn things off, there's a difference between turning it off and disconnecting its power. And I'm going to, so according to Natural Resources Canada, what percentage of your home's electricity might be used by gadgets and appliances that are on standby? So this is something called phantom or vampire loads, which are basically the loads that are being drawn by an appliance when you're not using it. So your TV, your VCR, your stove, your microwave, all draw energy when you're not using it. And it's a shocking percentage of energy use that it can use. A study that I read out of California suggested that 35% of the energy used in the lifetime of smaller electronics will be used while the unit is on standby. So a third of the energy the thing is ever going to consume, it's when it's not in use, which is pretty outstanding. So the answer to this question is 10%, which seems like an easy target to stop, to cut off. And we were pretty split there between respondents, between those three options. So you can unplug stuff that you rarely use. You can unplug stuff when you go on vacation. Give your appliances a vacation as well, as they say. There are what's called advanced power bars, which you can use, that you plug into the wall and then you plug the electronics into, and they can either be set up on timers, so they'll automatically turn off after a certain amount of time, or they can be set up with masters and slaves. So you can plug a TV into one port and then all the associated accoutrement with your TV into the other ports. And when you turn your TV off, everything else gets turned off at the power source as well. Another sort of more involved way, but isn't terribly complex, is to wire outlets to a switch. So you can wire, in a double port outlet, you can wire singles to a switch, and you can wire both to a switch, and that way, from the room, you can turn on the electronics in the room with a switch on the wall, which is much more convenient than getting down and unplugging it and plugging it in every time. Another way to reduce appliance electricity use is by monitoring. So this, similar to benchmarking, monitoring, getting that data feedback has a proven impact on people's energy use. So the watt meter, which the Sustainability Commission will have available at the library, is one tool that you can use at the device. So you can plug your fridge into it and see how much power your fridge is drawing. There are other units that can be used at the panel. So your main electric circuit board, you can hook units up that clip to all the circuits in your house and monitor electricity flows through those circuits. And some of them will load to an app on your phone. So it's another way of getting data feedback of different electricity use in your house, which can help inform behavior changes. Finally, when they die, buy Energy Star. It's not just a gimmick. There are real energy requirements to meet Energy Star. There are going to be differences within that. So the top freezer fridge versus the bottom freezer fridge are going to be different, even though they will be Energy Star. There's a calculator that Energy Star has online called Flip Your Fridge Calculator, which will help you assess the return on investment as well as the greenhouse gas impacts of your current fridge versus moving to a new fridge. So if you think you're on the cusp there, that calculator can help you make that decision. And then Fortis also has an appliance cost calculator where you can punch in the energy use of appliances you're looking at, and then it'll give you a lifetime expected cost to run that appliance, which will allow you to lean more towards the efficiency end of the spectrum. Finally, I'm just going to show this is a tool. Oh, I don't have it up. So Fortis website has a great website, great webpage just dedicated to energy saving tips. And you can see on the top bar here, it covers many of the subjects we just looked at. So water heating will come through. A lot of the stats I used tonight I pulled from here. Gives you different tips, gives you videos on how to do it. It's a nice spot to go to for reference if you're looking for easy behavioral and sort of easy efficiency changes to make. I'll send that information out in my final email as well. All right, so that brings us to the Q&A. So I'd like to open it up now for question and answers. I'd like to do this audio-wise, just so people can ask their questions verbally. So I'm going to ask you to put up your hand if you have a question, and I will unmute you because I don't think I can unmute you all at once. So you can answer your question verbally and we can get going there. I mentioned earlier that Alex and Terry are here with us. They have both recently been through the energy audit process with an energy advisor. So if you have questions about specific experiences, they might be able to add their experiences to that conversation. So Andy, looks like you've got a question here.
Yeah, I wanted to, it's specific to the energy assessments. So Rosin went through an energy diet program, and Terry would give me the timeline on that. I think it's almost a decade ago now, at least. I had an energy assessment done at the time, and I'm wondering, and of course I've kept those records. I'm wondering if that assessment done over at least a decade or more ago is still relative today, and can I use that information to apply to you know, granting bodies, et cetera, that might offer some opportunity for me to do some upgrades.
This came up at our last talk as well. Bruce, do you know any details around?
No, yeah, you can't use it. It's just time limited. I guess most of the reason for that is the state of the house at the time of the evaluation, and if it's too old, renovations could have been done on it and stuff. But there is, I believe it's a number of months it has to go back. For greener homes specifically, I did look into that. I had an answer for it, but it's certainly not as far back as you're going. It's about maybe 6 months to a year, I think, or less for greener homes.
So greener homes, you're referring to a specific program there.
Oh, right. That's the current federal grant program. And then there's Better Homes BC, which is the provincial one. And of course, the Roslyn one is added on top. They're all kind of available now. But Greener Homes specifically needs an EA to take part in that program. You need an interguide assessment, but you can't use an older one. There's a cutoff for that. If you want, give me an email, anyone that needs to know that question. But for the vast majority of people, you will need a new one.
Okay, good, thanks.
There's a couple of questions in the chat box here. One question you might be able to answer, Bruce, is how much, I'm assuming, does it cost for a typical EA for a bungalow? Can you answer that, Bruce?
Right. So I think it's around $800 for the D file, and then around $3 for the E file. So we were just looking at this today, actually, all across Canada, the different rates, and that's competitive with most rates across Canada. That's approximately what we charge for them. So the D file is the pre-retrofit file, and for greener homes, you also need an E file, which is the post-retrofit evaluation, which is shorter and just confirms the upgrades have been done and upgrades the InterGuide label.
Alex and Terry, I was wondering if you guys would be willing to share your experience with an energy advisor, and how it helped inform the decisions you made and are making around your projects.
I'm just going to jump in for a sec. I think, sorry, I didn't get the price right on that. I don't think it's 800. I think it's 600. Sorry.
Okay.
Apologies.
So 600 for the single assessment.
Yeah.
Okay.
Yeah. For the first one, and then
Right.
it depends. For some, you don't need the second one. For some of the granting programs.
Alex, why don't you, my energy guide, my audit was for a new house construction, and it was in 2015. I was digging through my old things, so it's 7 years old. So it wasn't a retro, and it was a new house construction. Alex, is yours? Can I put you on the spot? I mean, I'm happy to jump in too, but maybe yours is a bit more current.
I was just looking mine, COVID time. I thought it was more recent, but it's November 2020, so more recent than yours. And mine was definitely a remodel. Yeah, so background, a few of you know this, but my house is very large. And I have lots of guilt about that. But we also have geothermal. And so we wanted to do a remodel for 3 different reasons. Energy efficiency was number 1. There were some structural things we want to address, which is number 2. And then aesthetics, which was not unimportant, but it was number 3. And so we went in trying to figure out how big a remodel to do, how to even size this thing, how bad off we were. So we started with the energy assessment, which surprisingly said we weren't bad at all, which is, as Ken knows, Ken has all our details, is a lie. But I guess it just means everybody else is a lot worse. But so from an ROI point of view, our energy assessment remodel doesn't make a lot of sense. From where my values stand point of view, it makes a lot of sense. So the energy assessment helped really big picture for us. It helped really understand, would it make sense to replace the doors and windows? And the answer is, yeah, probably. But it was a lot more optimistic, I guess, on where we stood than I thought we'd be. But it helped me rationalize a very large remodel, is the best way I know how to say it. I thought it was very useful. It was a really good first step. I would push back on the idea of a detailed roadmap coming out of it. I think it was a broad brush roadmap of, showing, that if maybe we want to insulate our walls, maybe we want to look at our hot water heater, but it didn't. The benefit trade-off, how much it would cost to do those things versus how much benefit we would get. I ended up turning to we have a construction, we're going to do the remodel this summer. And we have a really strong construction firm that's going to help us. But I ended up turning to a designer architect to sort of bridge the gap between the two. He's very Pat Fritsch. He's very highly trained in passive houses and a lot of the testing and a lot of the energy modeling and really working through the details of, okay, so what is the cost benefit trade-off of and integrating in some of those other priorities. You know, if you have to do this structurally anyway, if you want this aesthetic effect. So yeah, I found the energy assessment as a good, how big is this bread box? Where would I start to look? But then trying to narrow it down. I could have, you know, in listening to this talk, I probably could have rolled up my own sleeves a lot more. And I know more than the average Joe, but I had no interest in rolling up my sleeves to the level of that detailed trade-off. So I found the conversations with Pat to be incredibly helpful. And I probably used, I don't know, you had said to talk for like 2 or 3 minutes. I think I probably did that, so I'll stop.
That's perfect. And Ken, go ahead. Did you have something to add? Sorry, you're still on mute.
One of the biggest benefits I got from the energy modeling that was done way back when, 2005, was actually the blower door test, which told me how really, really leaky my old house was. And it was very easy to cut it, you know, to find the big leaks and seal them and reduce the amount of leakage by 50% just on the big leaks. So the blower door test was a huge benefit, more so than some of the other recommendations, which were, a lot of them I thought were just common sense at the time.
And I agree, Ken. I just was surprised that our blower door test wasn't worse, to be quite honest. And so we had death by 1,000 paper cuts as opposed to a really big hole to fill.
And Terry, you used yours for a new build, which I didn't realize, but maybe you could talk about how it informed that process.
Sure. Yeah, this is it's been fun sort of listening to this and dredging up all these old memories. So a bit of background: I built a smaller home. It's a carriage house actually next to my main residence, which I'm in right now. So you see my heat pouring out of my skylight behind me. But I really had a strong desire to build a super efficient small home, and I was really excited, and I had this little motto in my head. I wanted to heat it with a light bulb, so I built it. It was brand new ICF construction, right through to the rafters, right through to the trusses. So the walls are 3-inch ICF with 6 or 8 inches of concrete with another 3 inches of ICF. So it's a perfect seal building. I spent as much money as I possibly could on windows. They were obscenely expensive, but because it was a small house, it was, it wasn't relatively, I felt like a good investment. I couldn't have bought better windows. I tried. And then I had a drop truss roof, and I filled it right with 24 inches of Roxel. So there's about R90 in the ceiling. So it had a super great envelope. And what I did with the energy guide after, I mean, there was some incentives, and I can't remember. I think it was pretty modest. I might have got $1,500 back for hitting the Energy Star. I hit a rating of 85 out of 100. So when they did the modeling for my house, and again, the forms look quite a bit different than the ones that Bruce was showing. So these are older ones, and I didn't have a blower test or any stats on that, but I hit an Energy Guide rating of 85 and got a little sticker, which is probably, and the rest of it all comes down to, I think, what Ken was talking before about behavior. So we heated it in-floor heating and did a combi boiler and used gas to heat both our water and the radiant in-floor heat. And, you know, in the coldest month of the year, for the first few years, it was my gas bills I can remember were $40, and that was with hot water as well. So that part worked out pretty good. And I think the, you know, the energy audit that I did when they modeled my house was more to satisfy my own curiosity about how good a building I did. But again, as Ken, so they gave me that rating. But again, as Ken might say, it's all about your energy bills and how hard you drive your car. It's an efficient building, there's no question. And the audit was, I guess, just a verification to a degree of the effort and what we put into the house to make it tight.
So you had that audit done after it was built. It wasn't a part of the design process.
Great.
Okay. Oh, nice. Bruce, did you have something to add?
Yeah, I like all the talk about, is it worth it to get an energy audit? And sometimes it is, sometimes it isn't. For the grants, you have to now. So if you're considering a grant, it's worth it, because if you're doing anything that you're going to get granted for, then get the audit. But one thing I tell people a lot is you kind of have to know what you're doing first. It sounds kind of weird, but if you get an energy audit and then you don't do anything, then you're kind of out of pocket for that, for the federal money. So if anyone has questions, feel free to give me an email about that. I can answer it. The other thing is, if people, it's not the low-hanging fruit for energy efficiency upgrades is sometimes it's pretty apparent if you do a little bit of research. And once you've done the research a little bit, you learn more about it. Maybe you get more interested in it, and then you can do it yourself. So like you say, the do-it-yourself energy audits is a pathway for learning. And learning is great, because when I go into a home and I talk to the people, most of what I do is just try and share information and assess, you know, try and find low-hanging fruit, what's going to be cost effective for them. Like, you know, there's lots of energy efficiency upgrades that are certainly not going to give you a whole lot of economic payback in energy savings, but some are. And it's finding the ones that are and doing them, because you can save money. And you know, the low-hanging fruit is something you can often just do yourself. But having an energy advisor coming in is valuable, especially in this granting environment where you get the money back right now. Because I see a lot of people, you know, there's low-hanging fruit there. It's just a no-brainer to get that done. Thank you.
And can I just add one last thing? And I just realized when you said, when did I get mine done? It was obviously November 2020, and now I'm going to get the work done this summer. I don't know how I would have timed it to get the energy assessment in time to get the rebates. Like if Bruce said it's 6 to 9 months, I just think you have to be, I was really walking in going, what should I do? Should I do it really big? Should I do it small? Should I do it medium? And the energy assessment very much helped answer that question, but there was no way that turnaround from the answer to that question to the actual work on mine was going to be within that window. So I think it's just really important, if you're doing it for the rebates, to be really clear about that timeline and to make sure you have your ducks lined up and you're not as wishy-washy as I was up front. Because otherwise you're not going to be able to get that. Like, we won't qualify for the rebates given that timing.
Interesting. Ken, did you have something to add there?
Yeah. Point to make to do-it-yourself people. Many of the rebate programs require the work to be done by a licensed contractor. So if you like to do the work yourself and you're competent, it might not be worthwhile going for the rebates, because it could cost you a lot more in the long run by using a contractor as opposed to doing it yourself. You've got to weigh up your costs.
Yeah, that's a very good point. I ran into that problem personally as well. So it's something to look at. Get a quote before you value that rebate too highly. Bruce, did you want to answer Margot's question?
Oh, right, embodied carbon, yeah. Let's see. What was I going to say before that? Yeah, I'll just do the embodied carbon. Embodied carbon is a great thing to consider along with economics. I put them both together. Does your energy efficiency upgrade make economic sense? If you're doing it for CO2, like emissions, does it make sense from a CO2 perspective? In order to find that out, you need to know the embodied carbon of the materials that you're using and to factor in. So it's a complex equation. There was a question about a heat pump. If they last 10 to 15 years and you're replacing it, factor that in if you're looking at reducing greenhouse gas emissions. It's something that is, as an energy advisor, I typically will just try and direct people to do their own research because it's kind of a personal thing. It's not something that I do for people, but there are tools out there that you can assess embodied carbon of various upgrades with. And it's a good journey to have because there's a lot of differences in materials in the embodied carbon that you might use.
Yeah, so in the first presentation we gave a couple weeks ago, we talked about embodied carbon, and it is going to be something that we talk about through the rest of the presentations. So we're going to bring it up as a variable and try to suss out some of those numbers as best we can, at least relative to other options. So you get a sense of the best way forward. Dirk Lewis actually sent me an article today or yesterday on the CBC, which said that what was it? The most environmentally friendly house is the existing house or something like that, basically emphasizing that the energy put into your home that's already existing, you can maintain that energy by doing a retrofit. So the retrofits you do to your existing home are going to be more energy efficient, have lower embodied carbon than starting fresh, which is part of the reason why we're promoting this and doing these talks. Jim asked about the lifespan of the heat pumps. I can't comment on that, Jim. I know that there are technology changes around the liquids that are being used in heat pumps, because like fridges, those coolants have very, very, very high GHG, greenhouse gas potential. And so there's some question about that coolant leak and the lifetime impact of that leak on the greenhouse gases of the product. I know that there's technological improvements that are getting less greenhouse gas intensive fluids in those units. We have a talk the entire talk is going to be on heat pumps in March. I believe it's the second Wednesday of March that subject, if it's not answered in the presentation, there'll be experts there that can answer that question for you, Jim. And why is renewable energy more expensive? I'm not sure. I might put Freya Freya's with us. I'm not sure if Freya has an opinion on this. If she does, she can raise her hand, but I don't know why renewables. I think it goes with, why are electric vehicles more expensive? We subsidize oil and gas way too much in this country, and we don't subsidize new energies and new materials enough. But it doesn't look like Freya's going to ask that. I will look into that more for you, and I will send a better answer to that out in an email with all the documents from tonight's presentation that I'll put together. So that if people want to dive a little bit deeper in any of the subjects, they can. Any closing comments? Looks like we're through the questions here. Any closing comments from the panel? Ken?
I just wanted, La Rochelle was asking about solar. So when you do the follow-up, can you just put pointers to the solar articles in the past from the SC?
Okay, yeah, sure.
That'd be great. Thanks.
Yeah. Go ahead, Ken.
Yeah, I've got I'll call it a hot potato question to put to Bruce. The Hot 2000 climate zone map that was issued in November 2020 directs energy advisors to use the Soyuz weather data for Roslyn. How do you get around that? It's obviously wrong, but do you have to comply with the NRCan directive to use a Soyuz?
No. I mean, I just picked the closest one personally. I think there's a lot of, like you were saying before, Hot 2000 as a model. When I go into a house, I don't know all of their, I need to make judgment calls a lot of the time. So as you said before, it's not meant to be completely accurate. So we do our best. And the closer we can get to an accurate model, the closer the model is, and the better, the more value it is. So that's my answer there. There's a lot of problems with Hot 2000.
If you submitted EnerGuide information to NR Canada using, say, Cranbrook weather data, would they accept that or would they reject it? Because surely the EnerGuide reports and EnerGuide labels are issued by them.
Yep. They it depends. If they QA'd it and they decided it was an issue, then they would reject it. But this is kind of more of a technical thing that might be for another conversation. Feel free to email me about that. That'd be good to talk about.
Yeah, I've been emailing NR Canada for the last 6 months and not got any satisfactory answers.
Ken's been like a dog with a bone with this question, Bruce.
It looks like Freya did say she could respond to that.
Oh, yeah. Freya, are you unmuted there?
I think I am. Why don't I start with the kind of the conversation around the Hot 2000 climate data, and I think it was, is it Ken? Ken, you were talking about it and has been super proactive around raising some of the issues around both the new homes and also obviously the retrofit and the climate data that's actually used within the region. So obviously it has a greater impact on Roslyn, but also across kind of that lower Columbia area as well. This was discussed by Building Standards, Safety Standards branch in a meeting I was in, I think it was end of November, kind of December. They are looking into it specifically around the energy step code. NRCan were also at that meeting. So there is a working group that's being set up to look at how we can actually improve that that data set. Specifically, there's a number of kind of locations across the province where it is providing kind of inaccurate sort of data. So my understanding, certainly on the energy step code, is Energy Advisor can't actually submit the files using, for example, Cranbrook weather station. So we're going to be looking at sort of other ways of managing, so we're not using kind of Sawyer's data for certainly this part of the region. So sorry to say, it's work in progress. On the positive side, it's taken some time, but certainly the province and NRCan are recognising there's actually an issue. So that's sort of positive. I think the other question that was raised was around why renewable energy is more expensive. And I think that one's kind of a complex one, and I'm not quite sure if the question is around local renewable energy versus, you know, we're quite fortunate here in BC that we do have a large amount, or the majority, I think it's 98% of our energy is from kind of hydro and renewable sources. Certainly the smaller kind of more domestic or localized energy, it is a little more expensive. Part of that is just the initial upfront capital costs, I think, but that's probably not addressing what the real question behind there is. So a bit of clarification on that would be useful.
Great. thank you very much for jumping in there, Freya.
No problem.
All right, any more questions? It looks like we got that. All right, so if there are no more questions, I'd like to thank our panelists for joining us tonight, Bruce, Alex, Terry, and Ken. We appreciate your time and sharing your experiences and your knowledge with this process. We have our next presentation is on Thursday, March 10th. We're going to be covering, what are we covering? Air tightness and ventilation. So we're going to have a certified designer and installer of heat recovery ventilators there to talk about those. Because as Bruce mentioned, when you tighten the home, you run into ventilation issues. And so looking at the house as a system and trying to address some of the knock-on effects of any retrofit action is another sort of cornerstone of these talks and what we'll be trying to do. So until then, thank you for everybody for joining us. I'll follow up with an email with some supporting documents if people want to dive deeper on any of this stuff. And we'll see you in a couple of weeks.
Thanks much. See you later.
Thank you.
Thank you.